Hello everyone. So today I'm going to be guiding you through a comparison, side-by-side view of Bio-Rad's ImageLab 1D image analysis software and our Phoretix 1D image analysis software. Now, the Bio-Rad ImageLab is a very well-known piece of software, and anyone that's bought a Bio-Rad ChemiDoc will have used it because it's the software that you get from Bio-Rad for free when you buy one of their devices. I've used it quite extensively during my PhD, and it's good. But basic, it's for Bio-Rad, their emphasis is on selling the equipment, the hardware, and the illumination stages, the gel devices. Whereas for us, the software is the only product that we do. So that's where all of our focus is. So ImageLab is free, but does that mean it's good? Let's find out. So I'm going to do a side-by-side comparison to see how much time you can save by using Phoretix 1D. Now, Phoretix 1D is compatible with all of Bio-Rad's hardware, as it is compatible with pretty much any gel doc or scanning device on the market. So even if you do have a gel doc device, you're not locked into the Bio-Rad ImageLab software. So if as part of this analysis, something sticks out to you, like, oh, I was finding that difficult within the ImageLab software, and you seem to be able to handle it quite nicely in the Phoretix 1D software, come get a free trial of our Phoretix 1D software from our website, try it out on the images that you've already got from your gel doc device, and make the decision for yourself. But there are alternatives out there beyond the software that the manufacturer provides. Now, before we start, ImageLab is available on Windows and Mac. Phoretix 1D is available on Windows and Mac and Linux and the latest versions of Snapdragon processors, so ARM PCs. I'm not sure if the Bio-Rad software is compatible with ARM PCs. I didn't see any mention of it on the website, but they are fairly niche for now. But I don't think there's any mention of Linux either, but I may be mistaken. So what I'm going to do is I'm going to open up the same image, one of our kind of stock images that we've got that we use all the time, and run through the role of an analyst and see how each software handles it, which is quicker, which is easier to use, that kind of thing. So I'm not an expert in ImageLab, so there may be a few instances where it's slow because I am slow, not because the software is slow, or I need to find a button or something like that. I want it to be a bit more real world, but of course with the Phoretix 1D software, I am quite adept. I've got quite a bit of knowledge and experience in using it. So whilst this is a side-by-side comparison, obviously I have a bias towards our product. Please observe it as you will, without bias. You could always try out Phoretix 1D for free. It's not going to cost you anything, and make up your own mind. So first thing I'm going to do is open an image and let's see what we can do. So let's just come through. I'm going to open the same image on both pieces of software and we'll go from there. So the first thing I'll do is I'll open both images are going to be the TIFF, so let's go for this. Okay, so the first issue is unsupported RGB color. Only 8 and 16-bit grayscale images can be loaded. I don't know if that means that the ImageLab software can't handle multi-channel TIFFs, but certainly within our Phoretix 1D software, we can handle multi-channel images. So if you want to do things like total proteins, if you're trying to observe ratios of band intensity between different different antibodies or different proteins, we can do that. We can support that within our Phoretix 1D software. So that's certainly a limitation. If that's the, I'll just open up the image I was trying to open so that we can show that we can support it. So this is a 4-channel image, and we can open it perfectly fine in the Phoretix 1D software and kind of separate it down into its constituent channels, different color channels. But that seems to not be capable within the ImageLab software. So I'm just going to pick a different image. So let's see if we can find one that's just a single channel image that it's going to accept. So obviously as well, it said it will only support up to 16-bit TIFF images. So presumably anything larger will also, any higher bit rates will also not be suitable. Sorry, I'm just kind of trying to find something that's going to open here. I think we've got a lot of, might have to open something really basic to try and perform this. I'm struggling to find something that's actually going to open. Oh, this is not the start that I intended to this video. This is not like I got you a setup. Um, Here we go. So we can see here we've got gel 3, so we've got an image here. I don't know how we would bring up the, there we go, view image overview. Oh, no, I kind of just want to bring up the, like the image information. There we go. So this is an 8-bit image, so data range between 1 and 255. No one else has been performed yet. Nothing else I can really see beyond that. So let's just open this within Phoretix as well. So this is gel 3, gel 319. I'm aware this is not the world's most interactive video at this point, and I can only apologise, but you are watching a video on Western blot analysis, so I don't know how much excitement you were expecting. So here's the same image within the Phoretix 1D software, and apologies that the screen's kind of squashed. I've decided to do it side by side rather than alt-tabbing between the different ones, because then it's just going to make it very difficult to follow, so you'll just have to accept that the scaling is not ideal, but I mean I can always pop this out and kind of show you the image within the 3D view here. So this is the same image, we've got the same amount of information, it's an 8-bit image, single channel, we've got probably a bit more information here. Now, so we've got the width, we've got the height, we've got the bits, that's it. So the first step, obviously, is to, well, let's just run through their analysis pathway and we'll run through ours as well. So we've got the auto analysis. So this will do low, high. We've got similar things for the band detection. We don't have any molecular weight. Let's just put some on because there is a molecular weight ladder on this image. Yeah, let's just go for let's just hit low and see what happens. Okay, let's try high then. Okay, maybe I'm not using that function for the. Okay, maybe I'm not using that function correctly. I don't know. In terms of Phoretix 1D, we don't have this kind of automatic analysis. What we do have is predefined protocols, which I can see that they have here. But I think this also includes gel imaging step, which ours does not, because we don't concern ourselves with that. Now, I don't think there's a way to go back. I might just have to reopen the image. Give me a second. I don't think there's a way to go back once you click on that button. Unless it's... Oh, sorry, it was just open in the background. So let's go for image tools first. So you've got basic flips, 90-degree right, left, custom rotations, crop, an invert button, and a merge button. So I'm assuming, right, so this is similar to our ability to create a multi-channel image. Interesting that you can create your own multi-channel image, but you can't open one. So maybe there's a special file format that the Bio-Rad software relies on to be able to perform that function. So we have similar. So we have the ability to, if we come along to our image, we have the ability to edit our image. Now we've got flips, rotates, crops, free rotates, but what we do is when you perform these changes, you actually save it as a copy. So you've always got the original to go back to. You can never save over, the original image. So you've always got that as a copy. I don't know if Bio-Rad software does that as well. Let's just run through a crop. in both pieces of software, I think they're probably going to handle it pretty similarly. Finish crop by right-clicking on the image, crop. So what this has done is just opened it. It applied the crop in the software, but it's not allowed you to save a copy of the cropped version. I guess you would have to export it. Within our software, if we want to do a crop again, it's very similarly click and drag the points. I mean, pretty much everyone knows at this point how to perform. We're all standardized around a pretty similar method for cropping here, and then you would save it as, and then you would save it somewhere, and then you would open it again, so you'd be working on that version. So I'll run through that. I'll follow the procedure, just so they're even, they're comparable. We're working on the same images. So if I come through and open my test image here, you'll see again. So what has happened, the difference between this image now and the image that the Bio-Rad software has performed is when we've cropped out that extra stage area, we've applied a recontrast to the image. So whenever you bring an image into Phoretix 1D, it tries to pick an automatic range of values and auto contrast adjustment to give you the best visualization of your image. When the image changes, it changes that to adjust that, whereas the Bio-Rad software hasn't. So you can see our bands are a little bit brighter now. We've kind of changed the contrast, with this here using the auto function when we brought this image in. So that's why it looks slightly different, but it's the same image. So that's the image tools, that's the image analysis tools. If we wanted to create a multi-channel image, we would be able to do it from the edit image function. Now, let's go through to the lane of band section. It's kind of more interesting, more what people want to be doing. So if I come through to lanes, so I'll just try the automatic lane detection straight away. So the Bio-Rad software has not done a great job here. Again, I'm not trying to be disparaging, but there's no real way around saying that was good. So that's going to need manual intervention. If we just come along and detect lanes on our software, we've still not done a great job, to be honest. We've done a better job. We've got closer, but it's not perfect. Probably to do with the fact that it's an 8-bit image and the resolution is not great. So both images are going to require manual adjustment. However, if I just use the area of interest function within Phoretix 1D, maybe I can get closer just using the automatic lane detection function before we start doing the manual intervention. Nope. Classic. So both images in both pieces of software are going to require manual intervention. So I don't know how I delete these. Alright, so I can't just click and drag. Yeah, I have to delete each one manually here and select yes. Right, so there are 1, 2, 3, 4, 5, 6, 7, 8, we'll go for 23. So I need a box of 23 lanes, and if I just zoom out a bit here, I could probably bring this down. And then depending on where I want to place this, dealer's choice really, if you want to place it at the top of the wells. So that's the lane box that we've got, but you will see that these are slightly bent lanes. So to reposition, change its shape. So I can bend the boxes slightly. I don't know if I can move individual lanes. Just frame. I can see set width, background mode. That's bands. I can't see a way to kind of set different, because obviously this molecular weight ladder lane has smaller bands than we do for our product DNA, protein, whatever it may be, in this band. So I'm unsure as to how we would cope with that situation. So maybe the image lab software does always assume all of your lanes are of the same width. If I come across to the Phoretix 1D software, again, you have to tell it how many bands you have. Click, left click and drag. And again, at the beginning, it assumes all of your lanes are the same width. But what we can do from here, we can bend it to match the different lanes. What we can do is we can change the lane width universally, so we can make them larger or smaller. But we can also edit them individually, so we can add their name here, and we can come down and make some bigger than others. We can bend, so we've got a little bit of a bend in the lane here, so we can bend this lane individually to try and capture all of that band information. And bend it here to match up, because it's more bent. The bend is not uniform throughout all of the image. So this is actually quite a good image, I guess, for us. It's not chosen for that method, but to be able to show you the power that you have over the individual lane shape. So if you wanted an accurate analysis in this image lab software, it's going to be quite difficult. With Phoretix, you can be very accurate. Oops, didn't mean to do it. You can be very accurate with where you place your lanes. And again, we can give our lanes names. So this will be followed through to the report, through to the CSV export if you need, if you want to label different samples and you want that to be part of the report as well. Right, back to the Bio-Rad software. I'm not going to waste too much time because people's attention spans not huge. And it's not going to be a very interesting video for you to watch. So I'm just going to fly ahead and assume that we can't do that level of editing within the Bio-Rad software. So adjust background. So you can see here we've got the lane profile for one of our lanes. Lane 8, it tells me here I can move along. I'm not sure why it's so small. There we go. So we can see here we've got our bands, what our band look like visually, and our background subtraction. So right, okay, so this is how this one works. The grey area is the background that's going to be subtracted, and then the red line is our band information. So that makes sense. Now, it seems to be that the only option I've got here is for rolling ball background subtraction, because I can see the disk size is changing, which is what we used to call rolling ball subtraction. But it doesn't seem to be that I have any choice in the matter. So yeah, I'll just go ahead and apply this value. It does appear that the image lab software does have per lane background subtraction, as the Phoretix 1D software does, which is good. But it all seems to just be around one technique. It's always rolling ball, and I don't know, can't say if it's if it's per channel background subtraction technique and strength like we have within our software. But yeah, let's say that is, apply that to all lanes. I'll close that down. So there's my background subtraction performed within Phoretix 1D. Turn off that. Ooh. I'll just turn off that view that we've got there. It's a little bit distracting. Apologies again for the fact that this is scaled massively. There we go. Let's bring that down. So here we have one of our lanes, lane 1. We can turn on as many as we want if we want to view them all at once, which isn't something we could do in the Bio-Rad software. You could only view one at once. And we can see how our background subtraction methods are affecting our data. So of course we've got rolling ball. As you change the rolling ball, I think I'm making too small a change for it to be noticed here. If I zoom right in, as you change the rolling ball percentage size, you can see the background subtraction measurement changes. So we've got the same interactive functionality in the Bio-Rad software as in the Phoretix 1D software, but we've also got all of these other background subtraction methods: constant value, profile minimum, image rectangle, classic. And then of course we've got fully manual background subtraction, where you can define point-to-point background subtraction. So you've got full control basically. You've got absolutely full control over what you declare as background or band, positive, whatever you may be referring to them as. So that's how we handle it within the Phoretix 1D software, and of course we can apply it to only active lanes and all lanes, just as the Bio-Rad software did. Let's move through to band detection. So we've got the band finder within the Bio-Rad Image Lab software. We've got low, high, or custom sensitivity, and you can apply it to all lanes or a single lane. And we don't have the ability to apply different background subtraction methods to different lanes, but that's a good idea, and that's definitely something I'll put on the development pipeline. But yeah, you have custom sensitivity and advanced, which I think is probably similar to these options we've got here. So we've got a noise filter, got sensitivity, percentage max peak, yeah, band limit. But we've also got low, high, and custom as well. So we follow a similar kind of ethos on that. So let's see how we detect low. Okay, let's see how we detect high. So we've got some in here. We've not detected those ones. So high intensity, again, we've not detected many. If we go on the low, do we detect any then? So we've actually detected more on the low than we have on the high. So we've actually detected these faint bands that we weren't able to detect with the Bio-Rad software straight away. But this isn't a great image. It's probably going to need manual intervention. You'll see what I did there is what I was struggling to do before on the Bio-Rad software is if I right click and drag, I just delete those bands straight away. Within the Bio-Rad software, I guess I need to right click on each band, or right, so I need to click on delete and then click on them. So marginally easier in the Phoretix 1D software. You can left click to add a band, or you can right click and drag to delete band or bands. If you want to add a band within, like add a manual band within the Bio-Rad software, you've got to click it and then adjust, I guess. Yeah, adjust where the edges are, and that's going to be hard to see on this video, I can imagine. So yeah, you've got to come in and then you've got to adjust the edges with the adjust tool. But interestingly, if I turn on lane profile, right, so I can do it in the lane profile here by turning that on, but it's a little bit hidden when you're just doing it on the image. But you can't view the image and the lane profile at the same time. You certainly can't interact with each one at the same time, but you can kind of snap this view. We can do a similar thing within Phoretix 1D in terms of getting a larger view of your lane. So this is fully interactive. We can draw lines, we can import bands, we can split bands, we can delete bands from this view. And when you're done, just close it. So we've got a similar setup as the Bio-Rad software has there. And again, if you want to add bands, you just left click. And if you want to adjust them, you would come in and adjust them just on the image here. So you don't need to keep going click, tool, adjust, click, tool, adjust. You can just do it all within the kind of the default setup that we've got here. If I just bring this across, you can see that it stretches there. So that's how we handle band detection, manual band editing, manual band removal, things like that. We can also add fixed size bands. So if you always know which size in pixel your band wants to be, you can turn that on, just left click and be on your merry way, rather than relying on an auto adjust. It's quite rare that you know exactly how big you want your band to be, but we support it because some of our customers have asked for it. I don't know what these buttons do. Display gel options. Oh, this is just kind of different view things. Switch to 3D view. Okay, so that's similar to the view that we had before. But I don't know if you can export this as kind of a presentation image as we had before. So flying through this, I'm sure I'm not doing this justice, this piece of software. Nope. But I'm just doing it as someone that would be like new to the software and doing a direct comparison. So molecular weight calibration. So within the Bio-Rad Image Lab software, we've got multiple predefined standards, and you can create your own. It's exactly the same setup. No, exactly the same setup we've got within the Phoretix 1D software. We've got a number of built-in, predefined, kind of commercially available ladders, but you can also create your own template and use that as well by defining the steps and the size in kilodaltons, base pairs, percentage, pH, whatever it might be that you're working with. You do that all within here. And then once you've defined your standard, you can come through and just click the lane that your standard is on. So select standard lanes. So my standard lane is number 1. But what we can also do within the Phoretix 1D software is have multiple standard lanes. So if you click another lane, it will also apply the molecular weight ladder to that lane. Gone a bit awry because we haven't got 2 molecular weight ladder lanes in this image. But what it will do is it will join them up. And by joining them up, it uses them as reference points to account for any warping in the gel, any experimental difference across the length of the gel that might mean that your bands have slightly moved in position. It's hard to explain unless you've seen a really smiley gel, but it allows you to accommodate for smiley or frowny gels to make sure that even if your gel is a bit wonky, we can still get accurate measurements in terms of molecular weight sizing. I don't know if the Bio-Rad software supports this kind of functionality as well. Oh, hang on. Yeah, so I can click the bottom ones. Yes, so it does support the same functionality as well. So we've got the same, we're aligned on that one. The regression methods, we've got linear, point-to-point, logistic, cubic spline. We support slightly more, exponential, quadratic, first order Lagrange, which is point-to-point. So we do have a wider range, and we can of course copy this this calibration curve to your clipboard for importing and things like that. Don't know if that's an option within this software. That's molecular weight. Now, quantity calibration, let's do this. So select a reference band on the gel. I completely realized that didn't realize there was this little slider at the top. So we'll pick a reference band, we'll pick this one. Select that band. Oh, sorry, I have to select that first. There's my reference band. In Phoretix 1D, we select it and add it, or you can select it and press the A key to quickly add it. So I'm assuming, right, so again, I probably should have had that on the whole time. The analysis table shows up at the bottom just as ours does, where it shows you all of the different measurements that you might be looking at. So we can be looking at a band table or a lane table, which again, lane statistics, lane and band table that we've got here. So I'm assuming that has just gone ahead and select a reference band. I assume that's just gone ahead and made relative quant. So that's just done everything as a percentage. We are, all right, okay. So our relative quant we call normalization. So everything's normalized to one band. I did see a normalization function here somewhere. I think it was when I was doing the lanes and bands. Normalization. Right, so that's a normalization channel. So we do have normalization channels if doing total lane protein or using housekeeping proteins on a multi-channel image, but neither of these are multi-channel, so let's not get into that. So what they're calling relative quantity here, we call normalization, which would just be pick a band that represents your 100%, click on use selected, we've got relative normalization here, and it will do exactly what this has done. Absolute quantity, I imagine, is, yeah, it's the setting up of a calibration curve. So you would select multiple bands, you would tell it the quantity of the band, or what that intensity measure was for, related to, etc. And then you would select a regression method, or a method for your line, and select your units. And again, we are unitless within our software, but you can select a unit in here. I think you can just type in a unit. Yeah, you can just type in a unit. So then you can choose your different point-to-point, linear. So it's doing the maths for you, but it's not showing you this calibration curve. There we go, standard curve. So this is a separate window that you have to open as well. Molecular weight standard curve. Yeah, that's what we had before. R squared value not available for a point-to-point, and that's correct. So that's how you view it. I don't seem to be able to copy and paste this, as you can from the Phoretix 1D software, or export it as a presentation image for a paper or something like that. So I think you'd be limited to a screen grab on that one. But yeah, within our software, you can kind of see all the data all at once, all the time. We don't really do windows within windows. Whereas obviously in this software, you've got to kind of find it a little bit. I guess they use the screenshot method. Yeah, so they use the screenshot method for their export to presentation image, whereas we have things like export presentation image, and you've got control over contrast, overlays, annotations, cropping, things like that before you do it. But of course, you can always screenshot as well if you prefer to do that. So that's quantity calibration, absolute and relative quantification. Annotation. So I'm assuming you just left. Nope. Right, so you can add text and arrows separately. So let's go test. Add an arrow here. So actually within our software, we have the ability to perform an annotation pretty much anywhere, just by holding control. So we can add an annotation in here, and again, you can control the font size, the color, the arrow size, the arrow color, things like that. But we can do this in pretty much any view, and we can turn them on or off. So we can annotate images, we can annotate the bands, or we can also annotate the lanes as well when you're looking at the lane profile. So if I just go here, so we can export this image and expand it up with your annotations all part of it. So you can annotate your actual data rather than just your image. I don't know if that's possible within no, so I don't think it's possible to add annotations to your data within the Bio-Rad Image Lab software, but like I said, we can do this anywhere. So in the bands section, hold control, left click and drag, got all these options. You can do it wherever you want to annotate your data. But apart from that, you've got a lot of very similar editing functions to be able to make sure that the annotations that you're adding, the pointers, the color of the background, the color of the text is going to show up on your image. Don't know. Yeah, same functionality within Bio-Rad, but you can only do it at the end of your analysis, whereas we can do ours at pretty much any point and do it on the lane profile as well. While editing text, press Shift and Enter to add a line. will that just mean carriage return? Yeah, so end to ends and carriage return drops you down a line. That's data annotation, and then volume. I'm honestly not sure what volume tool is meant to be. Is this right? So this is the ability to define an area and measure the volume. So this is more of a toolbox function, really. So you can measure lane volume, but we can do that. We do that automatically anyway. So if you come down to the lane table, we can get lane volume right here. Background subtraction, local or global. Not sure on the alignment. It's probably the alignment of the text here. So I think the value of this is being able to just define an area, and you want to compare volumes within the image that are not strictly bands. So they could be rectangles, they could be round sections. I think this is probably more to do with the fact that Bio-Rad, sell this image analysis software as being 1D and 2D, whereas we just do Phoretix 1D as 1D. So they probably have to cope with things like spots in 2D gels, whereas we have other software to do that. So I'm not going to be able to do a direct comparison because this is more, this aligns more with the Phoretix Toolbox product that we've got, that I'll do some videos on at some point. That's more like that than it is like the Phoretix 1D software. So again, I guess you can do quantity calibration on that. So finally, we'll come through to the results section, the exporting. So I assume, as this is a table, you can kind of copy and paste it to Excel. So you can copy it to the clipboard and you can export it to Excel in a file. Again, we can do that with these buttons here, copy to clipboard, export to a file, things like that. Now, report. So this is the report that Bio-Rad has performed, that the Bio-Rad Image Lab software has performed. Oh, it's very small. Oh, there we go. So we've got one image at the top there. We've got all of our lane images. It's very similar to the kind of report that Phoretix 1D actually outputs, to be honest. It tells you that automatic detection was used, what the background subtraction was, but it breaks it down on a per lane basis, whereas Phoretix 1D breaks it down into a per channel basis, a per experiment basis. So I think you kind of have to have everything turned on. I don't see any view options in terms of turning on or off data, whereas we can turn on or off the different data that we want to include within our exports. So if you don't want to include lots of this information, you don't need to. If you only care about the things that I've got turned on here, as long as they're ticked, you can generate a PDF report for just all of that information. And you can also choose individual lanes that you want to export a report on rather than having to export everything. So if I generate a PDF report here, it does take a little longer in the Phoretix 1D software, I will give it that. But again, we're exporting here, whereas the Image Lab software, if it was to export, print report, again, it is slightly quicker with the Bio-Rad software. I will give it that, but I'm guessing it's because it's just a slightly simpler report. So when we have exported from our, this is the report that you would get. So we've got our annotations on there. I think we had them on the Bio-Rad software, and this is a 45-page report. So the reason ours took a little bit longer is it's a little more in depth. So all the lane information, all the manual bands, whether they were added manually or automatically, all of our lane information with images, image slices, all of the band detection overview here. So we've got a lot more images within ours, a lot more high-res images of the overall analysis. So we've got our molecular weight ladder. That I don't think the molecular weight ladder, the actual lines for fitting were on the Bio-Rad software. We've got all of our calibration curves. Again, I'm not sure if they were in the Bio-Rad report either. But yeah, this is the PDF report that you get out at the end, and then you get kind of all of the metadata from the image that you've used as well. So I hope this was educational. If you're still watching, well done. This is quite a dry video trying to compare two different software packages that are designed to solve the same problem. Please, if you want more information, if you're considering, if you run into any problems, things that you can't do in the ImageLab software and you want to try an alternative approach, please check out our website. Go and get a free trial of the Phoretix 1D software. Try it on your own images in your own lab. Get in touch with us if you've got feedback for things that neither software does and you'd like to implement that in the next version of Phoretix 1D. We're all ears. Please let us know. And yeah, follow the links in the description below. Give us your feedback, comment, go get a free trial, try it out for yourself, and make your own mind up. Until next time.